So this one here says, how long would it take for an investment to double at an annual interest rate of 7.5% compounded continuously? Well, let's see here. If I have $100, it's going to be $200 when it's doubled. $300, it's going to be $600 when it's doubled. Let's just do this. If I have $1, that means it's going to be $2 once it's doubled. Notice how I have my principal here. That's what I'm starting with. This is what I get, my A of t. That's the amount after a certain amount of time. Okay? And I'm saying that I'm going to double. Okay? And it wouldn't really matter what number I use as long as I have this here and this is double that. So we're going to have that 1 times, and we'll have e raised to the 0.075 times t. Because I don't know what t is. I'm going to solve for t. Well, if I get rid of that 1, I divide by 1 on both sides. No big deal. I have 2 equals e raised to the 0.075 times t. And let's take this back again. If this were, $500 and this were 1,000, when I divide by 500 on both sides, I'm going to have 1,000 divided by 500, which gives me 2. So see how it's going to work out regardless of what I start with? I'm still going to have 2 over here. Well, then I'm going to take the natural log of both sides because I want to get rid of that e. We've been doing that. So I have the natural log of 2 equals 0.075 times t. And then I divide by 0.075 on both sides. And what I'm going to put in my calculator will be this. Natural log of 2, close those parens, divided by 0.075. And that should give me my answer, which is going to be about 9.24 years. Really round it to whatever we want. In this case, it didn't say anything, so I just put nearest hundredth, so 9.24 years. Usually it might ask for like nearest year, in which case we do 9 years, but it would pretty much be your call or nearest year for most of these. Alrighty, we have a similar problem here. How long does it take for an investment of $5,000 to double if the annual interest rate is 6% compounded continuously? Well, this time we're actually given a dollar amount. Okay, well, and feel free to pause this at any time and try it on your own. If I'm given $5,000, I'm starting with $5,000, right? And I'm compounded continuously, so 0.06 times t. I don't know what t is going to be. Well, what's my investment going to be if I double that? Well, it's going to be $10,000. Now you'll notice what I was talking about in the last problem. If I divide this by 5,000 because I want to get rid of that, what's 10,000 divided by 5,000? It's 2, dose, if you will. So I get e raised to the 0.06 times t. And now I'm just like the last problem. I bet you probably finish this out. Hit pause if you want, and then try and finish it out. So I'm going to have the natural log on both sides. Cross it out. I'm left with natural log of 2 equals 0.06 times t. It's still very similar to the last one. Divide by 0.06. What I'm plugging in my calculator is natural log of 2. Remember those parens. Divide by 0.06. And I'm left with about 11.55 years. If I were to round this one to the nearest year, it would be 12 years. But I decided to round to the nearest hundredth. So 0.55, 11.55. Not too bad. Here's something a little different. If it takes a certain amount of money, 3.7 years, to double, at what interest rate was the money invested? And we're going to be talking about compounded continuously. This one fails to mention that it's compounded continuously, but it is. So let's see here. If it's going to double, we know this one. We know it's going to be 2 over here, and we can just do 1 here. Those are simple numbers to work with. And we have e raised to the, well, I don't know what my rate is, but I do know that it's going to be times 3.7 because that's how much time I have. The same process applies. I'm going to divide by 1, which gives me 2 equals e raised to the r times 3.7. Taking the natural log of each side. Gone. Natural log of 2. Remember, if it's like tripled, you're going to see 3 here instead of 2. It's not always going to be 2. All right? So I have r times 3.7. If I divide by 3.7, in my calculator I'll have natural log of 2 divided by 3.7, which equals about 18.7%. All right? What you get is 0.187 as your decimal, but remember, if you want to put that in a percentage, you got to move that twice, and you get 18.7. So that's the interest rate we would need if we wanted to double our money in 3.7 years. Any amount of money compounded continuously would take an 18.7% interest rate for 3.7 years in order for it to double. Awesome. So cool. Man, that's some great knowledge right there.